brace yourselves for a mind-blowing revelation that will shatter everything you thought you knew about the universe. Quantum energy teleportation is not some far-off sci-fi fantasy. It's real, it's happening, and it's rewriting the rules of reality as we speak. Imagine a world where energy zaps across vast distances without ever crossing the space in between, like a cosmic magic trick that defies the laws of physics. This isn't just a theory, it's a jaw-dropping breakthrough confirmed by cutting-edge experiments that are sending shockwaves through the scientific world. Get ready to dive into the chaotic, pulsating heart of the quantum vacuum, where the impossible becomes possible, and the future of technology, space travel, and even the fabric of space-time itself hangs in the balance. Buckle up. This is going to be an emotional, electrifying ride that will leave you questioning everything. Picture this: the vacuum of space. That vast, empty void we've all been taught is just nothing. Wrong. It's a seething, frothing cauldron of quantum fluctuations, a wild dance of particles, popping in and out of existence faster than you can blink. This isn't some sterile, lifeless emptiness. It's a cosmic ocean, teeming with untapped energy, vibrating with potential. For years, dreamers and scientists alike have whispered about harnessing this vacuum energy to power starships, to bend space-time for warp drives, or even to cheat the laws of physics. They said it couldn't be done. They said it was impossible. But guess what? They were wrong. Dead wrong. Because right now, in labs across the globe, researchers are doing the unthinkable. They're teleporting energy through this quantum chaos, moving it from one point to another without it ever traveling the space in between. This is quantum energy teleportation, and it's the most insane, heart-pounding discovery of our lifetime. Let's break it down, because this is where things get wild. The universe has some ironclad rules. Energy can't just appear out of thin air. Conservation of energy is non-negotiable. Nothing, not even information, can zip around faster than light. These are the cosmic speed limits, and the universe is a strict enforcer. But here's the kicker. The universe also loves a good loophole. It's like it's winking at us saying, "Go ahead, try to outsmart me." And outsmart it, we have. Quantum energy teleportation, or QET for short, is the ultimate cosmic hack. It lets us pull energy from the quantum vacuum in one place and make it reappear somewhere else, without it ever crossing the distance in between. No wires, no beams, no tricks, just pure, unadulterated quantum wizardry. And the best part? Scientists have already proven it works. This isn't some dusty theory sitting in a textbook. It's real, it's measurable, and it's happening right now. To understand how this mind-bending feat is possible, we need to venture into the weird, wonderful world of quantum mechanics. Don't worry, we'll keep it simple, but hold on to your hats because this is where reality starts to feel like a fever dream. First up, quantum entanglement. Imagine two particles, let's call them particle A and particle B, created in a lab. These particles are entangled, which means they're connected in a way that defies all logic. If you measure particle A and find it spinning one way, particle B, no matter how far away it is, instantly snaps into the opposite spin. It's like they're having a telepathic conversation across the cosmos. Einstein called this spooky action at a distance. And he wasn't kidding. It's downright eerie, but it's real. And it's the key to everything we're about to explore. Now let's take it up a notch. Entanglement isn't just about particles twirling in sync. It's the foundation for something even crazier. Quantum teleportation. Here's how it works. Suppose you've got a third particle, particle C, with some unique quantum information, like a secret code. You want to send that code to particle B, but you don't want to physically move anything. No problem. You let particle C interact with particle A in a special way, and poof, the quantum code jumps to particle B, even if it's light years away. Particle C's code is gone, wiped out in the process, but particle B now has it, like it was beamed there by magic. This isn't science fiction. Quantum teleportation has been done in labs, with quantum information zapped over hundreds of kilometers, even from Earth to satellites. It's the backbone of future tech, like quantum computers and the quantum internet. But we're not here to move information. We're here to move energy. And that's where things get absolutely bonkers. To teleport energy, we need to scale up our game. Instead of just one pair of entangled particles, imagine 10 pairs, all linked in that spooky quantum way. Each particle has a spin, and that spin is tied to a tiny bit of energy. Here's the setup. The particles are floating in a magnetic field, where one spin state, let's say up, has slightly less energy than the other, down. If you measure all 10 particles, you'll get a random mix of ups and downs, and the energy balances out to zero. Boring, right? But here's where the magic happens. If someone measures their 10 particles first and tells you exactly which ones are up and which are down, you can cherry-pick the ones that let you extract energy. You're not creating energy out of nothing. You're just playing the quantum game, smarter. The person who measured first had to put in energy to do their measurements, more than you'll ever get out. But it feels like you're pulling energy from nowhere, like you've hacked the universe itself. This is cool, but it's still a bit clunky. You've got to physically share those entangled particles first, which isn't exactly practical for teleporting energy across the galaxy. So let's ditch the particles and go straight to the source, the quantum vacuum. This is where the real insanity kicks in. The quantum vacuum isn't empty, it's a bubbling stew of virtual particles, flickering in and out of existence, driven by the Heisenberg uncertainty principle. This principle says that nothing in the quantum world can be perfectly still or perfectly known. Even in the empty vacuum, energy fluctuates wildly, averaging out to zero, but never truly at rest. It's like a cosmic pond, rippling with tiny waves that seem random, but are secretly connected across space. Every point in the vacuum is entangled with every other point, a vast web of quantum correlations stretching across the universe. Here's the game changer. Those correlations let us do something unbelievable. By measuring the vacuum at one point, you can learn something about the fluctuations at another point, even if it's on the other side of the cosmos, and with that knowledge, you can extract energy from the vacuum at that distant point. It's like dipping a bucket into the quantum pond in New York and pulling out water in Tokyo without ever sending anything between them. This is the heart of quantum energy teleportation, and it's not just a thought experiment, it's been done. In 2022, a team of brilliant minds used entangled qubits to pull off this stunt in a lab, teleporting energy faster than it could have traveled naturally. They did it again in 2023, using a quantum computer to confirm the results. These experiments are the smoking gun, the undeniable proof that QET is real, and it's here to stay. Let's paint a picture of how this actually works in the quantum vacuum, because this is where the emotional weight of this discovery hits hard. Imagine you're in a lab, staring at a device that's probing the quantum vacuum. You make a measurement, and in that instant, you're disturbing the delicate balance of the vacuum's vibrations. Those vibrations, which usually cancel each other out to look empty, now tip into an excited state, like a pond rippling after you toss in a stone. That ripple carries energy, positive energy that you've injected into the vacuum. Meanwhile, across the lab or across the universe, your partner is waiting with their own device. You send them your measurement results, not the energy itself, just the data, through regular old channels, slower than light. They use that data to tune their device, and boom, they pull energy out of the vacuum as if it materialized from nowhere. Their device sees a negative energy state, a dip in the vacuum's usual chaos, and that missing energy is now in their hands. This isn't just a cool trick, it's a profound moment in human history. Think about it. We're not just moving energy, we're tapping into the fundamental fabric of the universe, the same quantum fields that give rise to every particle, every force, every star in the sky. It's humbling, exhilarating, and a little terrifying all at once. You can't help but feel a surge of awe, knowing that we're peeling back the curtain on reality itself. But there's a catch, and it's a big one. The universe isn't giving up its secrets easily. The energy you extract is always less than the energy you put in to make the measurements. It's like the universe is saying, "Nice try, but I'm still in charge." Energy conservation holds firm, and relativity stays unbroken because the information still travels the old-fashioned way. But that doesn't make this any less revolutionary. To really grasp the stakes, let's zoom out and think about what this means for the future. The amount of energy teleported in these experiments is tiny, barely enough to flicker a light bulb. And if we ever manage to do this with the quantum vacuum itself, the range will be limited, and the energy will still be small. But don't let that fool you. This is just the beginning. Quantum energy teleportation could be a game changer for quantum computers, where moving energy efficiently at the nanoscale is a holy grail. It could power nano devices that revolutionize medicine, computing, or energy production. And here's where it gets really emotional. This isn't just about gadgets. It's about understanding the universe at its deepest level. QET experiments are giving us a front-row seat to the dance of entanglement, the quantum vacuum, and the very nature of space-time. Now let's talk about the big, juicy implications, the ones that make your heart race and your mind explode. Quantum energy teleportation creates something extraordinary. Negative energy density. That's right, negative energy, the kind of stuff that sounds like it belongs in a sci-fi blockbuster but is very, very real. In the quantum vacuum, when you extract energy at one point, you leave behind a region where the energy is less than zero. This isn't just a quirk, it's a key to unlocking some of the wildest ideas in physics. Negative energy is what you need to stabilize wormholes, those hypothetical tunnels through space-time that could let us zip across the galaxy or even travel through time. It's what you need for warp drives, bending space-time to move faster than light without breaking relativity. We're not saying we're building wormholes tomorrow, but QET is giving us a way to study negative energy in ways we never could before. Compare this to something like the Casimir effect, where negative energy pops up between two metal plates because certain quantum vibrations are blocked. That's cool, but it's limited. You need the plates, and their presence cancels out the negative energy's effects. QET is different. It lets us generate negative energy remotely, without physical structures getting in the way. That means we can study how this negative energy warps space-time, how it interacts with the fabric of the universe. Will it lead to warp drives or time machines? Probably not. The universe is stingy with loopholes that break causality. But even if we never build a starship, QET is helping us unravel the mysteries of quantum entanglement, the vacuum, and the curvature of space-time. It's a window into the soul of the cosmos, and that alone is worth getting emotional about. Let's take a moment to reflect on the human side of this discovery, because this is where the tears start to well up. Imagine the scientists who first made this work, the sleepless nights, the endless calculations, the moments of doubt when they thought it might never happen. And then, that heart-stopping moment when the data came in, when they saw the energy teleport from one qubit to another, defying everything they'd been taught. This isn't just a win for science. It's a testament to human curiosity, to our relentless drive to push beyond the impossible. We're not just discovering new physics, we're proving that no dream is too big, no idea too crazy. This is humanity at its best, reaching for the stars and finding something even more profound. But we're not done yet. Oh no, we're just getting started. Let's talk about the experiments that brought this to life, because they're the kind of thing that makes you want to jump out of your seat and cheer. In 2022, a team used the spins of carbon atoms in a molecule, something you'd find in paint or glue of all things, to create entangled qubits. They stabilized these qubits with nuclear magnetic resonance, the same tech behind MRI machines, and used them to mimic the quantum vacuum. One qubit got a jolt of energy, and its entangled partner, in a state that should have had no energy to give, somehow coughed up the goods. The energy transfer was faster than it could have happened naturally, like it skipped the middleman of space itself. A year later, another team used a superconducting quantum computer to replicate the feat, proving it wasn't a fluke. These are the moments that define a generation, the kind of breakthroughs that kids will read about in textbooks decades from now. So what's next? Where do we go from here? The truth is, we're standing at the edge of a frontier we can barely comprehend. Quantum energy teleportation is in its infancy, but its potential is limitless. Imagine a world where we can move energy with pinpoint precision, powering devices smaller than a grain of sand. Imagine quantum networks that use entanglement to share energy and information in ways we can't yet dream of. Imagine probing the quantum vacuum to uncover secrets about the Big Bang, black holes, or the birth of the universe itself. This isn't just about technology, it's about who we are as a species. It's about our need to explore, to understand, to connect with something bigger than ourselves. But let's not get too carried away. There are challenges ahead, and they're not small. Scaling up QET to work over long distances or with the actual quantum vacuum is a Herculean task. The energy involved is still minuscule, and the measurements require insane precision. And then, there's the pesky fact that you always lose more energy than you gain, thanks to the universe's strict bookkeeping. But none of that dims the excitement. Every great discovery starts with a spark, a crazy idea that sounds impossible until someone makes it real. Quantum energy teleportation is that spark, and it's lighting a fire that will burn for generations. As we wrap up, let's take one last moment to soak in the sheer wonder of it all. Quantum energy teleportation isn't just a scientific breakthrough, it's a love letter to the universe, a reminder that reality is stranger, wilder, and more beautiful than we could ever imagine. It's a call to action, urging us to keep exploring, keep questioning, keep dreaming. Whether you're a scientist, a student, or just someone who loves a good story, this discovery belongs to you. It's a piece of the cosmic puzzle, a glimpse of the infinite possibilities that await us. So let's hold on to that feeling, the goosebumps, the racing heart, the sense that we're part of something truly extraordinary. Quantum energy teleportation is real, and it's only the beginning. The universe is waiting. What will we discover next?